Hey guys and gals, welcome to this lesson from section 6.2 on the converse of the Pythagorean theorem. Okay, please turn to the P page of your critical concepts section of your binder and give yourself the following title, Converse of the Pythagorean theorem. Now, the converse of the Pythagorean theorem is really an if-then statement about the Pythagorean theorem. So, I'm going to ask you to, underneath your title, write down the if-then statement that I'm highlighting right here in your notes. After you're done, you're going to want to write the steps to using the converse of the Pythagorean theorem. Pause the video while you jot these things into your notes. Basically, the converse of the Pythagorean theorem will allow us to check if three given sides of a triangle actually form a right triangle or not. Now let's take a look at a couple examples. Example 1, determine if these side lengths form a right triangle. Alright, so we're going to start off by writing the Pythagorean theorem. A squared plus b squared equals c squared. And we want to make sure that we put our given side lengths in. Especially important that our longest side length has to be in the hypotenuse position, which is C. So we're going to put 13 squared right over here. Okay, it doesn't really make a difference which one our A and our B are, the two shorter sides. I always just like to put them in order from smallest to largest. So now I will square all of my terms. 5 squared is 25, 12 squared is 144, and 13 squared is 169. I will add my a squared and my b squared terms. 25 plus 144 is 169. And since a squared plus b squared is in fact equal to c squared, then we know that these do form a right triangle. And I'm going to just abbreviate triangle. Alright, example 2 looks like we have a diagram to look at with some side lengths of a triangle. Please make a sketch of this triangle. A lot of times students will look at the triangle and say, well, that is a right angle, so this must be a right triangle. However, a 90-degree right angle looks extremely similar to an 89-degree angle or a 91-degree angle, and if it is not in fact exactly 90 degrees, it will not be a right triangle. So we're going to check mathematically using the converse of the Pythagorean theorem. So I'll start with my formula. I'm going to look for my longest side. I've got 12, 12, and 24. 24 is the longest, which means that will have to be our C term. Okay, the other two are the same, so it doesn't matter which one I put where. And now I'll square all my terms. 12 squared is 144. And 24 squared is equal to 576. When I add 144 plus 144, I get 288. And 288 is not equal to 576. Since these two, a squared plus b squared is not equal to c squared, I know that this triangle is not a right triangle. All right, let's take a look at one last example. Remember, we're always going to start with the formula for the Pythagorean theorem. A squared plus b squared equals c squared. I want to be looking through my side lengths. Don't be on autopilot here, ladies and gents. I want to be looking for my longest side and make sure that's the one that gets put into the C position. Okay, now my 4 and 8 are going to go in then for A and B, and now I'll square all my terms. 4 squared is 16, 8 squared is 64, and 10 squared is 100. When I add my a squared and b squared, 16 plus 64 gives me 80. and 80 is not equal to 100. Therefore, I know these side lengths do not form a right triangle. All right, ladies and gents, I think you are ready to complete your checkpoint questions. And while you're completing them, enjoy the cute, cute puppies. Have a great day.